right? It was like a symbol, like equality. Here we have two or three concepts. We have tautology, we have contradiction, and also we have contingency. Tautology means that all of them, the result, the output is all of them true. There's no false in it. And maybe you have a contradiction, means that the output is what? As false. For example, to understand, if I say I have P and negation P, then or. Show me is tautology or not. So you know, P is what? True, false, right? No, just true, false. Okay. Now how about here? False, true. Now, or about, how about or? So because the result is fully true, it's called tautology. Okay. How about if I have P, negation P, P and negation P? We get what? True, false. Here will be false, true, and between them will be false, false. So it's a contradiction. Understood, dear? Yes, Kaka. Because just we have only one statement, P. 2 to power 1. If I have Q, then you are right. Understood, dear? So this is called tautology, a compound property that's always true. It's called what? It's called tautology. And the compound property is always false. It's called contradiction. And the compound may be true, maybe neither. So contingency. You can see from here, that one's tautology, that one is contradiction. About that one. Another question? Do you have any question about that one? Hello? Okay, now I'm going to add another extra things. We have De Morgan's law. What do you mean by De Morgan's? Here we are. We have compound. We have compound. We have two things. For example, P and Q. P and Q, sorry. P and Q. If I try to take the negation of them, the rule that distribute this negation operation, is called De Morgan's. And the result will be like that. Negation P or negation Q. So that one will change everything here, even the operation. Understood? How about P or Q negation? By De Morgan's law, we say negation P and negation Q and go on. This is called De Morgan's law, and you saw that one before, I think. Do you have any problem? Two statements are called, they are equivalent. So P equivalent to Q when, show me when, where the biconditional between them is tautology. The biconditional between them is tautology. What do you mean by that? We saw that before. We say that before, sorry. We say that, for example, these two are what? Are equivalent. On the truth table, you can say they are equivalent because the location are the same. You can see first, second, third, fourth, the same on the truth table. But if you try to be sure that, or to show them by the theoretical things, this one should be with that one should be tautology. So let me select that page. So I have what? I have P. Do not forget about that one. I have P implies Q. And what else? A. Negation Q then negation P, true, false, true, true. Sorry. True, false, true, true. It was like that, right? Okay. So he say what? Let me make some change here. Now he said, let me call that one as A, and that one is B. He said the A and B will be equivalent when if A by conditional B is tautology. So let me check, they are tautology or not? Yalla. Do you remember by conditional? If they are the same, true. Otherwise, false. Yalla. This one, the same, true. The same, true. So I got what? Tautology. Right? So you can say they are equivalent. This one is true. You can apply that information to all of the equivalent that you see. Do it at home between contraverse and inverse, right? We say that one, they are again are what? They are again equivalent. So do it, find it's good or not. Now we have what? Another truth table. Show the De Morgan's law are equivalent. Means that show that are equivalent is true by truth table. Show me. How do you know they are equivalent? How do you know this distribution is good, is correct? You can see from here. I'm not gonna solve for you, just look at here because they're easy. We have PQ, right? Okay, now we have P and Q. Now, or between them because I wanna or. How about after or? We need negation. So between them are, or between them. Okay. Now I'll get true, 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 and false. Then negation of this one will be false, 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 true. You can see from here. Sorry. Then C, that one, in my mind, that one will be A. And show me that one, the B. So here's B. I got that one. This is B. So tell me these two are equivalent or not? As allocation, F, 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 T. Yes, they are equivalent. Understood here? This example is important. This example important. And as well, which one also? That one also important. Tell you the distribution between these two. Before I am solving, I am going to leave that one for you as a homework. But I am telling you where's the important thing is where. You say that P implies Q is equivalent to negation P or Q. Where is it? Yeah. If I say P implies Q, I can also write like that. I'm going to use that one. The importance here is what, Kaka? Is when during the solving, maybe sometimes I say do not use the next section. I say do not use truth table. Just use property. Show me that they are equivalent. So during the showing the property, I'm going to use this change. Okay. So I say P implies Q is equal to negation P, then Q. To get the idea that they are equivalent, look at here. The answer is here. So I leave it as a homework for you. Understood, dear? Good. So maybe during the exam, I say show that, or maybe you are going to use that property to solving something else in the next section. You'll see. Also, example number 4, important. Why important? Because we have a distribution between two operations. Look, P or Kaka, P here, please. P or QR. QR. So how many statements do we have? 8. So look at the table. If you try to solve a table, look, we have 4 true, 4 false. Here, couple true, couple false. Here, single, single, and single. Understood? We are going to divide like the probability, as we say. We have 2 to the power 3, so equal to 8 row at least, at most. Okay. Then I'm going to leave also that one for you, which is easy. I say show that this one, A, is equivalent to that one, B. You can see true, 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 and 3 false. Again, 5 truths and 3 false, so they are equivalent. But my focus on what? Because later, again, I'm going to use that one like a previous one. If I have Q and R, I say that one will be equivalent to PR and PR. So we have, you can see P with R distribute with the 2 other, right? Understood what I mean? You can see distributed. Good. How about number 3? It look like the first. I say P and Q or P and R. The same distribution. Here we have or, here we have and in the outside. Here inside you have and, then we are or, and the change will be like that. This distribute. Understood, Wanya? Right? You know, you can put in your mind, if it's hard to you, say A multiply B plus C. It will be what? You can say A, B plus A, C. Am I right? So instead of that one, change that one to and, that one to or. You will get the idea. It's called distribution. Right, left side does not make a sense. So by the table, you can use that one. But for the property, we are going to just use that line, no more. Bashakaka, just that line. Okay, here's the table. Here's the property. You can see from here. 5 minutes left. So kindly be more energy. Okay. So he say what? P and T will give you P. Can you show me how? Yes. Which one? No, by truth table. True. True. Okay. So here, because we have tautology, right? This one's a tautology. So, and which one between them? And so it is what? Because and I'll get true and false with itself P, right? So the same thing. So that one means tautology. That one means contradiction, false, false, and you will get the rest of them. Of course, you know the negation of the negation is same, right? Negation of negation, same. And that one we can play with the location. It's called symmetry. Do you remember symmetry in the polar coordinate symmetry. So they are the symmetry, or it's called here commutative. You can sweep between them. If I have 3, 1, and they have the same logical operation or and, it's called association or associative. If I have one of them with the other, it's called distribution, and we did like that before, right? Now remember, here's the distribution, that one and that one. So these were very important. And of course, De Morgan's, we show that one also by truth table. I leave it for you, I remember. So we have a De Morgan's for and or. Also, again, we have this property. Can you show me that property? Can you show me P and Q then or equal to P? Or sorry, equivalent to P? How? Okay, show me.
Four possibilities.
For possibility, okay. So I'm going to show P or, wait, P or P and Q equivalent to P, right? I want to show that one. So here's, as you say, just give me 1 minute. Okay, we are going to put the truth table P. Yeah, you are right.
True, false, true, false.
Okay.
And so we have
Before
the or P and Q.
You are right. So it will be
true, false, false, true, and
false. Careful.
Sorry.
It's okay.
False.
And
you have to order it by P.
Thank you. So you did well. We solved the first bracket. Then now that the result of here with P or. Am I right? Good. So true or true? True. So P or P and Q. Okay.
True.
Again, true.
False.
False. False. So if you compare that result, you'll get P. Thank you very much. Understood, dears? That's how we got it. The same thing is true for the next. And of course, we say that P with the negation will give you tautology, and with the other will give you contradiction, right? Okay. Okay. Last thing, which is important, we are going to use for today. And no worries, we are not going to more. So do not hesitate. Just I'm going to give you to these tables. We have what? You saw that one, right? We say careful. And that one we see contrapositive, if you remember, Kaka. Contrapositive here, right? And that one is important again. And let me see. You can from here, you can see that one also. That one's for biconditional, that one for conditional. When we say conditional, we mean like that. When we say biconditional, we mean like that. So most of them, they are important. We are going next lecture. We are going to use this property in our demand, in our, in our lecture. Here we are.